Okay, hi, I'm Martin. We don't have a lot of time for introductions, and I've spent the entire day talking to you, so maybe we're also just going to skip that. I'm here to talk about cljdoc a bit, and I've given some talks on this. And this talk, I just want to focus on giving you an idea how you can use it in your day-to-day work kind of thing. And if that's boring to you, and you've already heard that, then use your free time to go to the cljdoc project in GitHub and start or watch it if you're feeling particularly inclined. Okay, so usually this slide comes in the middle, but yeah, demo time. And we're just going to rush through a couple of things that cljdoc does and what's special about it in my obviously biased view. First thing, cljdoc is a website that provides documentation for Clojure libraries. And it provides those provides that in a versioned way. So whenever somebody publishes a new version of a library, you can see the documentation for the old version still, and you will always have access to that. And there's like a very clear contract that documentation will not be deleted, and that you always are looking at the documentation for a specific version. Secondly, documentation can include stuff like articles, and so that can be really useful if library authors want to provide additional information to their documentation, like performance information or a guide to get started or that kind of stuff. And basically anything that renders nice on GitHub should be rendered nicely on cljdoc. Obviously, all documentation needs API documentation. That's really what you're probably coming for, and that's also supported by cljdoc. And I think there's one thing that deserves being highlighted here, which is that cljdoc supports Clojure and CljureScript in a very transparent manner. So you can see the documentation for Clojure and CljureScript side by side, and if there's a difference between a function and the arguments to that function, for instance, in Clojure and CljureScript, you'll see that accordingly. And I think that awareness, that platform awareness, is something that hasn't been there before in Clojure documentation tooling. Also, if they're very complex, like option maps and stuff like that, they will be formatted very nicely using zprint. In case you're familiar with zprint, which I'm very fond of because this just looks nice. And another thing that it can do is you can download documentation. So sometimes you're going to be offline for a while, or you're going to sit on a plane or a train or whatever, and you won't be able to actually Google your way to your solution as we usually do. Downloading documentation for later use in that case is a very convenient tool. This is also the foundation for something I will talk about in a minute. Now, with cljdoc, this is a website and everything is stored in a database and stuff like that, and that enables some really interesting stuff as well. And I think a fun one of that is that it enables us to figure out what is the longest doc string in the Clojure ecosystem. And this is the winner. I think, yeah, let it sink in. Yeah, it's longer than many READMEs I've written myself. So yeah, it's quite an impressive amount of work, and I think it also really shows up nicely how you can use additional formatting features like Markdown and docstrings to highlight how people can use your code, what they can do with it, what it's expected, the use of code formatting, lists, and all that kind of stuff can be really useful for you as a consumer of that library. cljdoc also works on mobile. I was personally bugged it didn't for a while. I really think nobody really cares, but it works on mobile. So I mentioned the offline bundle stuff is the foundation for something else, and that is the Dash integration. And I think that's something that's newish. Who here is familiar with Dash? Okay, cool. So you can now in Dash download documentation for any Clojure library that you want to use. You're welcome. And the nice thing here is that Dash is this very uniform interface. For those of you who don't know it, it's a very uniform search interface that you can. Yeah, I have 2 in my timer. I it's a very uniform search interface that you can use to look up documentation and that kind of stuff. And that's just really, really convenient when you work with the library a lot and you have to look up stuff occasionally. So I'm really happy I made that happen with the help of the original creator of Dash. Obviously, this is an open source project, and I spent some of my free time on it, but like also to make it sustainable and to make it live on, like it's important that it's not just me maintaining it and extending it. So if you feel like contributing, if that sounds like a project interesting to you, please consider dropping by and contributing. There is a lot of cool stuff that can still be done with cljdoc, specs, examples being two highlights. And there's a lot of nice reasons to contribute, which I cannot explain now because I'm out of time. But it's really a good experience, I hope. And I just want to use the last slide to thank all the people that contributed so far. There have been quite a few people that just came by and did like a very impactful work, and I'm very thankful those people did that. So thanks to them, and thanks to you for listening to me.
Thanks a lot for the introduction. As this is a lightning talk, let's really get into the matter immediately. So, as I already mentioned, it's about interactive command line interfaces, and I think you've already heard today quite a lot about one particular command line interface, which is the Clojure REPL, and that it is very powerful, which I consider positive. On the other hand, it requires Clojure knowledge, which sometimes at least could be a little bit negative if you want to hand out your applications to other people which are not the typical users of the REPL, like Clojure developers. So Cli-for-clj aims on implementing CLIs for everyone and to ease their use and implementation. Some words before, don't be afraid by this wall of text. I will guide you step by step through that, and I show you the important points. And secondly, you don't have to understand everything. It's more about the working principles, and everything else you can look up later if you're interested. So of course you have to include the dependency. The entry point for starting a command line interface is the start CLI macro, which is configured by an options map. And for defining commands, you need to have at least a command name, here on the left, test CMD, and a function which does something when you execute the command. You can include additional information, which will be displayed then in certain situations. Commands can also have arguments, and here is a completion hint, which I'll show you in a few bits what this is used for. And of course, you can also use functions which are defined elsewhere in the same namespace or in other namespaces as well. These are some advanced options I just used for this example. This, by the way, is a fully working, minimal working example, but don't worry about these options yet. I'll maybe tell something about them later. So when you start it, you'll get a prompt. I think we are all familiar with the prompts, and here I just entered the commands that were defined in the example, and you see the outputs of these commands, so that's quite basic. In addition, you get a help function which gets generated based on what you defined. So you see then information about the commands that you defined for Cli-for-clj. And you get the usual tab completion, like if nothing's there and you press tab, you see an overview of available commands. It completes the command if you typed it partially. And you will get some information if you type the command completely. You will get information about invoking it, like what are the arguments. And here also the completion hint, so to give you a hint what to do with it. Furthermore, the commands can be completely used in Clojure in a Clojure-style way. So this is just an example to show you that you can even, so for people who are familiar with Clojure, they can then tap into the full power of the REPL, so to say, because everything is based in the end on the REPL. And what I showed you so far is a classical scrolling mode. So you enter something, you get the output, you enter something, you get the output. So output and input are interleaved, which sometimes may be a bit of a worry if you have continuously scrolling things, so that your output gets always in the way of what you want to type. And for this, there is this alternate scrolling mode, which here in the highlighted is the separator. Below the separator is the prompt for the input. And above the separator, there is the output of what command was typed. So essentially, the typed commands are simply echoed. And of course, again, the results of that. This was now the application user perspective. Now switching back a bit to the developer perspective, There's also functionality for testing the command lines you define. So of course, again, you have to include the required dependencies. And then you can say, hey, I want to execute a few commands. Like here, I typed 2 commands, add and divide, which I want to have executed. And then there's functionality for executing them, and you get the result of evaluating that in your command line back. And then you can simply check with the expected results if that matches what you were anticipating. There are more features there which I didn't mention here, like persistent history, aliases or shortcuts can be defined. It's customizable to a certain degree, like what prompt is displayed and so on. And you can also do something which I called embedded CLIs, so you not only need to interact with them interactively from a command line, but you could also put that in a server. When you send commands to a server, you will get a reply back. And for example, I used it in a system with a message-oriented middleware where I execute the commands remotely, which made it a little bit easier to work with the system. So this is actually already coming to the end. There's more information on the GitHub page. You see the usual GitHub badges, like it's available on Clojures. The build is passing, luckily. The coverage. I also wrote a few blog posts about that, where you can find the URL there. Thank you very much for your attention. I think there were no questions, so I just kept it in just in case. And here is some contact information. If you want to have more information, I'll be roaming around, and you can also contact me through these email addresses. Please try to send to both of them just in case, because sometimes one of the servers is a bit funky, so to say. Thank you very much.
Right. Hi, I'm Robert. I don't have much time, so I'm going to assume that you know where Monoid is. And I'm also going to assume that you have some inkling as to what a free monoid might be. But just to give you an idea, it's basically a list where you can accumulate values and then use a monoid to sort of reduce over the list and merge them together in some way. Now, you can define monoids for quite a lot of things, but one of the interesting things that you can have them for is for functions. Now, in type programming languages, you can only do this for endo functions, so they're functions from one type to the same type, from int to int, ball to ball, or A to A, as a Haskell might say. But in Clojure, the binding operation for the monoid in this case is composition. You can compose the functions together, and the identity element is the identity function. Now, in Clojure, this looks a bit different. In Clojure, the type signature of a function is from object to object. Now, if you squint at this definition for a bit and avoid hurting me for the next 5 seconds, you'll basically notice that this is an endo function from a mathematical perspective. It's basically the function from the type of everything to the type of everything. Now, whatever Java does with this object at runtime is irrelevant for the flawed argument that I'm trying to make. But for all intents and purposes, it is a monoid, which means that in Clojure, I can basically compose arbitrary computations together and have a list of arbitrary functions that I can compose together later on, which seems insane. But I'd like to show you how you could use this to build something quite interesting. So I hope you can see this. Can you see this properly, hopefully? Yes? Yes? OK. So you can build a construct that can sequence computation using free monoids. You can do it to also execute your computation asynchronously. So in order to do this, you need to define a wrapper for it. And I'm going to call it a task. Now, this thing gets 2 parameters. The first one is basically the list of functions that I'm going to accumulate, the free monoid. And the second one is a result. Now, this is going to be a promise from a previous computation that has some value inside of it. Now, the second thing that you need is a way to create this thing. And what I want is sort of like a function that gets a body. And I want the body of the function to be sort of lifted in a function and be added as the first parameter of my free monoid. Now, the way you do this is naturally with a macro. So you create a macro, give it a body, then instantiate this thing, create a list, put it in a function, of course, and then that's it. Now, the second parameter, I told you it's a promise. I don't have a previous computation, so I'm just going to do future of nil. And now I have basically the thing that I wanted. I can do task of 1 + 1 is going to be there. Now, the third thing that I need is a way to sequence computation, basically add functions to my free monoid. Now, I'm going to do this with a primitive called then. Hope you like JavaScript. Now, the discipline here is that the input value for this f is going to be the output value of the latest function from my free monoid. Now, I can't enforce this here, but I can enforce it by the way I'm going to use this. So for now, let's just update our task and just const the function to my free monoid. And now I can do something like this. I can say 1 + 1, or whatever you want, then ink, then string, and then something like then print line. And you can see is they're sort of sequenced together, and they seem compositional, don't they? But they don't actually do anything so far. So at some point, I'd most probably like to run it. So let's create a function called run. And this thing will interpret my free mono. It's going to take the functions from the thing, if I could only type, and it's going to apply, compose them together. Now, the problem is I don't know what the input value of this function is. But if you remember, hopefully, my task has a result inside of it, and this has a promise from a previous computation. By the means that how I've built this, this is going to be guaranteed to be the input of my function. Now, I can't run my function directly because this would be synchronous executions. I've promised you synchrony, so what you do is something a bit more clever. Instead of returning the function executed, you return a task with an empty free monoid, like a consumed free monoid, and you execute this function in the future. And then you can do something like this. You can thread sleep for infinity, and then you can print line something. And then if you run it, it's basically going to execute asynchronously. And the beauty of this is that you can continue composing into this thing as much as you want. Or not this, let's say this. And it will basically continue your sequential computation. So now you have basically a construct for describing lazily, asynchronously executed computation in Clojure with free monoids. Thank you.
Okay, hello. I'm going to show you quite a few code examples, so let's get started. Here's a pretty basic Clojure function. It takes a list of numbers and returns a comma-separated string with only the odd numbers in. And this is an example of pointful function, because in mathematics, functions, they map values or points in some space to other points in other spaces. And here, x is a point in the space of Clojure values. And this function specifically tells us how to map this one point to another point. But there are other ways of writing this function without talking about any individual point. If you use comp for compose and partial for partial application, we don't have to talk about any individual point at all. Haskell programmers really love this style, and they call it point-free programming or tacit programming. And you sometimes see Clojure people doing it as well. We do have the comp and partial in core after all. But that's not really, it's a bit verbose. So what we do instead is use threading macros. And this is pretty neat. You have this flat list of just function calls, and somehow they are composed into one big function that handles what you want to do. Okay, we mentioned the X, but this is like Clojure is practical language, so we don't care about that. But now let's try something really hard. Let's try to insert a debug print in the middle of the thread chain. Because you can't just put print there, because it returns nil. So you have to split the chain, usually. You have to use let to bind the result and print it. Of course, you could write your own function that does the printing and then returns the value. And if you write your own function, you can always do it as an anonymous function. Just use do to chain the or sequence the effects. This is pretty pointful because we have the percentage sign. That's clearly a point we are talking about. But we can get rid of one of them by using do to, which returns the first value and then threads through. But now some of you may have noticed that now the order of arguments to print are in wrong order, but nothing that can't be fixed with one more threading macro. But it would be nice to get rid of the second percentage sign. There are two ways to do with this core, with Clojure core. One of them is to use thread as, which give us gives us full control of the threading, and then we can use the bracket expression to just put the threading expression wherever we want. Or the other way I can think of is to just shuffle around the threading macros a bit. Use thread first on the outside and thread last in the inside. This works nicely, but note that you can do it the other way around. So thread last outside and thread first inside. That's just going to mess up everything. So let's stop for a moment. Like, do I have a point? Not sure. Basically, you should learn that, or now know that any program can be written in point-free style if you are just creative enough with the threading macros. And if Clojure core doesn't have enough threading macros for you, there's this library Swiss arrows that has even more of them, and a new competing implementation Harpoons, which also works with ClojureScript and has different set of threading macros. So use this knowledge wisely, and that's all. Thanks.